This is Mrs. Dawson. Graph each set of functions on the same screen in the standard viewing window. Describe any similarities and differences among the graphs. A. Y equals x squared, y equals x squared plus 4, y equals x squared minus 3. B. Y equals x squared, y equals the quantity of x plus 4 squared, y equals the quantity of x minus 3 squared. C. Y equals x squared, y equals the quantity of x plus 6 squared minus 5, y equals the quantity of x minus 4 squared plus 6. So we'll begin with A. Standard viewing window is zoom number 6 for standard. We'll go to y equals and type in the first one, y equals x squared. Here we have a parabola of normal width that opens up. If we go back to y equals and graph y equals x squared plus 4, you can see that we have a parabola of the same width, however it's been shifted up 4 units. So for part A, we had y equals x squared plus 0, y equals x squared plus 4, and the third one is y equals x squared minus 3. If the pattern follows, we have a vertex of the parabola at the origin. For the second one, we've shifted that vertex up 4, and once we graph y equals x squared minus 3, I think you know what to expect. Let's take a screen capture of part A. You can see that we have the general form of y equals x squared plus k. In other words, if we add the constant, we have a vertical shift. For part B, once again, we'll begin with y equals x squared. However, the second one will be the quantity of x plus 4 squared. So we'll just clear this one out. Parentheses x plus 4 squared. And then the third one is the quantity of x minus 3 squared. One feature we can use with the 84 is to turn off and on a function. So we'll go ahead and turn off y3 and y2 by going over the equal sign and hitting enter. So here's the original parabola back, centered at the origin. If we turn on y2, by adding 4 to the x inside the parentheses, let's see what happens. It's shifted to the left 4 units. So we had y equals x minus 0, quantity squared was the original, y equals x plus 4, which we can write as x minus a negative 4, quantity squared, and the third one will be x minus 3, quantity squared. And once we turn that one back on and hit graph, you can see that we have another parabola of the exact same width, only this time it's been shifted to the right 3 units. So we have y equals the quantity of x minus h squared, and that is a horizontal shift. So let's take a picture of that one. So we've got part A, where we were moving the parabolas up and down, part B, where we're moving the parabolas left and right. So for part C, we'll once again begin with y equals x squared, but this time we'll have both transformations. X plus 6 quantity squared minus 5, and x minus 4 quantity squared plus 6. So back to the y equals. The original one is fine. The next one is x plus 6. We can just type over top of the 4 using the right arrow, and then minus 5. And then editing the third one, it's x minus 4 quantity squared plus 6. We're in sequential mode, which means when I hit graph for the y equals, we should see one of these graph at a time. Here comes the original, the second one, and the third one. As you can see, our original was centered at the origin. The second one had a shift down 5 units, and then a shift to the left of 6 units. And we can see that vertex by tracing the x value, which is -6. You can see the vertex is at -6, -5 for this one. And then the third one had a shift to the right 4 and a shift up of 6, which means our general form, if we put part A and B together, we have x minus h, where h is the horizontal shift, quantity squared, plus k, where k is the vertical shift. Let's take a picture of that. So we're to describe any similarities. Notice that they're all parabolas of openings being exactly the same. The differences are shifting up and down, shifting left and right, and then in part C, shifting both up, down, and left or right.